For various reasons, charging a lithium battery from an alternator is not as straightforward as charging a lead battery. In this episode, we'll be showing you how to best use an alternator to charge your lithium batteries and what happens if you don't. In the city of Bucharest in Romania, within the Victron dealership ATI Energy, is this setup. On the left we have a 230 volt 3-phase motor. The revolutions can accurately be measured using this control box, and we can see how many amps are required from this meter. The motor is our engine and is fitted to a frame. On the right hand side of the frame is our alternator to test. There is a normal alternator belt connecting the two. Our main battery is this 300 amp hour lithium battery. Although it requires a battery management system, as we are here and using it for tests, it's without one. We're making sure the lithium battery is around 50% state of charge at the start of each test. That's what this light box is for, discharging the battery between the tests. We are measuring the current into the battery using a Victron BMV 712 battery monitor and shunt. Before we start testing, we know that most alternators are not very efficient, which means that besides power for the batteries, it also generates a lot of heat whilst charging. A typical alternator has an overall efficiency of 50%, meaning that when it charges with 1000 watts, it also generates 1000 watts of heat. For the heat to be taken away, it cools itself with fans on the rotor. The faster it runs, the better it cools. This is why we'll be running tests at different RPMs. Our first test was at 3000 RPM. This produced a healthy 78.9 amps from the alternator. This speed kept the temperature of the alternator nice and cool at around 43 degrees Celsius due to the fan built into the alternator. Since the fan is part of the alternator, the amount of cooling is directly linked to the speed. The next test we conducted was charging the battery at half the speed, 1500 RPM. Note that this is still above the typical speed of an engine running idle. This test is still pulling a similar amount of current, 65 amps, out of the alternator, but the effect of the lower RPM and therefore less cooling on the alternator is significant. Its temperature increased so much it started to burn the internal coil. The conclusion from this test is that charging lithium batteries at low RPM results in the alternator overheating and possibly burning out. The Balmar alternator includes an external regulator that monitors the alternator temperature and battery temperatures and automatically lowers the output current by adjusting the field output to match the conditions. As we saw previously, a standard alternator can happily fool you into thinking all is okay as it's producing the amps required. However, the temperature is going up and up. On the Balmar, we fitted the optional temperature probe to the external of the alternator. This informs the regulator, and so the pull of amps is reduced, keeping the alternator temperature below the maximum value. Our initial test was at 2114 RPM. This produced a steady 50 amps. The regulator indicated an ambient temperature of 24 Celsius and 42 Celsius for the external casing of the alternator. We used a temperature monitor, and you can see at the top left of the device the alternator's internal temperature is around 74 degrees Celsius. Our next test was to increase the speed to the maximum the motor could produce at 3600 RPM. The Balmar alternator produced around 94 amps, but as the casing got hotter, the amps being drawn were reduced automatically by the regulator to prevent overheating. We kept the alternator running for around 30 minutes, and the temperature inside rose to 130 degrees Celsius, and even with an internal temperature of around 130 degrees Celsius, the Balmar alternator was coping. So on to the conclusions. What we've seen is that indeed issues can arise when charging lithium batteries with an alternator. The major difference in alternator charging between a lead-acid chemistry and the lithium chemistry is that due to the internal resistance of a lead-acid battery, the charge current is limited. While with lithium, the charge current can even exceed the maximum rated amperage of an alternator, which leads to a substantial risk of overheating and wear on the alternator. Especially at low alternator speeds, the so needed cooling is lacking. Most alternators can only deliver their rated current at high RPM speed, which works for a lead battery, but not for lithium batteries. A lithium battery will also draw a high current at low speed, causing the alternator to overheat, as we've seen. There are several solutions for this. One is to fit an alternator of such a size that even at idle RPM it will be able to deliver the accepted current by the lithium battery without overheating. Another solution is to fit an alternator and regulator with a temperature sensor like the Balmar that we've shown in this video. When the alternator gets too hot, the regulator dials it down to keep it within the allowed temperature range. Lastly, you can limit the current by installing a current limiter or DC to DC charger. The other issue, not demonstrated in this video, is that many lithium systems disconnect the battery from the charging source once fully charged. This can damage the alternator regulator if not done properly. Victron currently produces 3 pieces of equipment that can protect both your alternator and your battery system. Like we installed in the VW van install, we used a buck boost, a BMS 12200 that I myself use on my boat, and a new product coming soon called the Orion TR Smart DC to DC charger. We hope you found this video useful. Thank you from all of us for watching.